Good afternoon. It's late in the day here, but we are still in Luxembourg and we're in the middle of an incubator site. I'm here with co-founder and CEO of Molecular Plasma Group. Welcome, Mark. Looking forward to speaking to you about the future of organic chemistry and how it's actually been applied to your business at these difficult COVID times. Thank you very much, and thank you for having us.
Thank you very much for coming, Nigel. We love to have you here, and I appreciate the opportunity to present our technology to you and demonstrate how we will have a positive impact on the current pandemic.
So Mark, as I understand, you are a trained engineer and a serial entrepreneur. Now, before I get into the question of the day, we're going to take our masks off as we are 2 meters apart. A few years ago, around about 5 years ago now, you decided to take a new venture. You'd chosen your home here where you've been for the last 22 years in Luxembourg, and you looked at an incubator opportunity. So here we are, plasma. Does everyone understand plasma? No, they don't. So first of all, I'm going to ask you, tell me a little bit about the technology that you have introduced, and I'm really going to call this a disruptive technology, and what's going on with Molecular Plasma Group, and then we'll get into the question of the day. So tell me more.
Right. Plasma, to answer your first question, it's the fourth state of matter. Solid, liquid, gas. Next step is plasma. The sun is plasma, except it's a very high energy plasma. What we have is a unique technology that creates a plasma state but at extremely low energy levels, which then enables us to introduce organic chemistry inside that plasma stream and bond it to any surface. That today is absolutely unique to be able to do that with atmospheric plasma. You can do some of these things under vacuum, but you can't do it in an industrially scalable process, except here. We can do this.
When the business was conceptualized, there was a vision for applications in engineering primarily. Can you tell me about the core technology that is behind MPG and where is it going?
When we started the business, the core of the technology, put it that way, is that we are able to graft, covalently bind, for the techies, organic chemistry onto any surface, going from the most inert substrates like Teflon, for instance, to the most sensitive substrates like cellulose. It doesn't matter, we can do it on anything. And we do that in an industrializable, scalable process. That's the uniqueness of it. Now, when you understand what that core technology can do, then you realize we're changing surface functionalities in the broadest sense of the word, and you can start to dream, because the functionality is simply function of the chemistry you choose to create a certain function. It can go from simple amino groups to do an adhesion promotion that we were looking at or are looking at in industry and things like that, or epoxies or something like that, all the way up to complex biomolecules with secondary and tertiary structures like antibodies, enzymes, those types of things. That is the key of what we do.
So obviously now we're talking about a potential game changer. But let's have a look at the pharma space. And there's many challenges in antiviral and antibacterial. So where would you see the opportunities in that space, and what has happened in 2020 for your business?
Right. So when COVID hit, all the traditional industries that we were active in, like aerospace, etc., completely collapsed. But at the same time, I thought, our technology is so versatile. Quite sure we can do something in this crisis as well. So we started looking into the possibility to graft virucidal compounds onto personal protective equipment with our technology. I reached out to hospitals in and around Luxembourg, and the feedback was, wow, if you can do this, obviously at an acceptable cost, then this is amazing. We want it, and we want it now. So we started development work, because we really had to start from scratch. We've never done anything like this before. So we partnered up with the LIST Institute, from which we spun out originally, to do all the development work on MS2 bacteriophage, because that allows us to cycle fast, to demonstrate whether we could do this. And over a period of about 16 weeks, we ran somewhere between 500 and 600 different iterations of processes, of chemistries, etc. And today we've identified one natural chemical, so therefore inherently very safe, that gives us this amazing virucidal functionality, let's say, that we will graft onto personal protective equipment. Initially, the focus is on face masks, because the hospital management identified as a pain point. They say there's a real fear factor at some hospitals that people contaminate themselves by touching the outside of the mask and then self-contaminate or cross-contaminate. And by having this virucidal function on the outside of a mask, you break that cross-contamination chain. So that's what we focused on. That's what we're going to market with, together actually with our partner here at Luxembourg, initially a Luxembourgish hospital that invested in the mask making line. So we're partnering up with them, and we're starting to treat first rolls of their material to really go through that certification process and get it going.
So I understand that you were part in the early days of Fit for Start, which is an investment program that Luxembourg have put together to help innovators get off the ground and move forward. If we now look at blue sky 10 years out, you have a completely clean slate. Where can this technology go, and what are your aspirations for that technology?
Well, the Fit for Start program for us was absolutely crucial, and the entry point of Fit for Start for us was the bonding of antibodies onto a glass substrate. Actually, we did a proof of concept. Just to give you an idea on that one, because today that's a multi-step with chemical process that takes up to 16, 24, even more hours. We did that in 10 seconds with zero incubation time, nothing, just plug on, full functionality maintained. Yeah. Now imagine what that can mean. Yeah. So actually, when I did my pitch for Fit for Start to enter into this program, I declared that my dream was that this technology could really bring diagnostics, cost of diagnostics, way down in cost, and from a centralized model to a very decentralized model. So bring diagnostics, make it available to the entire population of this planet. That was my dream. I think we're on track for that dream. I think we have many steps to go, and the mask is one of them, but also this one will explode. But this will really be our stick in the ground. Yes, we can do this. Build a track record and make the dream happen.
Do you even see the application going even further, over to potentially as a coating that can go on to virtually anything that is implanted into first in human and can actually, is that possible?
Yes, it's possible. Without a shadow of a doubt, it's possible. There's development work to be done, but we can, with this technology, we can build layers, functional layers, barrier layers, and then you can go to controlled drug release. All these types of things are well within the capability of the technology. So yeah, there's a huge potential there.
So we are on day 23. Luxembourg is our 27th country that we visited. I have to say my brain is spinning now, thinking that we need to invest in MPG, if possible. So thank you very much, Mark, for your vision for the future. And I have to admit, it's kind of a bit of a wow moment. So thank you very much.
Well, Nigel, I'm glad you enjoyed your trip here and learned something. I'm very happy that you took the time to come and visit us to discover what we have to offer. And I'd like to close with Luxembourg's national motto: let's make it happen.